Hello and welcome to EE151, your introduction to electrical engineering. We'll be doing a number of different things in this course, learning a lot about electrical engineering and about the things that electrical engineers do, and equating you with what your future career might be like. One of the things that we're going to include in that is to take you through the steps that engineers go through when they want to take an idea and turn it into a product. We'll be also asking you to think about a design challenge. This problem will require you to do a little bit of thinking on your own, do some creative brainstorming, do some selection of design alternatives, do some analysis, build some prototypes, try things out, test them out, see how well they work. And in short, doing all the steps that engineers do when they're working on a new product development. In preparation for that, what I want to do right now is take you through some of the steps of a product design cycle, a typical product design cycle, so that you're acquainted with those steps and have a preview of what's coming ahead for you. Now, the steps that we're going to describe in this product development cycle are actually the true steps that are used in industry. So if you worked for a company and were designing a new cell phone or a new medical device, these are the steps that you would be going through if you were part of the design and development manufacturing team for that new product. You'll be doing this going at least halfway around the cycle with your design project, starting with an identification of customer needs and going through a prototype development. Now, we won't be manufacturing anything out of this other than your one prototype, but we can still talk about some of those phases and acquaint you with those as well. So to start with, any product development cycle starts with some idea. And that idea is trying to address a need or a customer or an opportunity that one sees in the marketplace. Hopefully a good idea, hopefully a new idea that no one has had before. And we take these ideas and turn them into a set of customer requirements. So we take our idea, we expand on it, we talk to potential people who might be interested in our product, and try to, from that, formulate a complete product idea of something that somebody might be willing to pay us for. From there, we move into the conceptual design stage, and what comes out of that is a product concept, a series of drawings, an architecture, a little bit more details about how such a product might be implemented, as well as a product specification, something that translates these ideas and these market requirements into the language of the engineer, that spells things out in a bit more detail so we have a goal to shoot for from an engineering standpoint. Following that, we turn the design engineers loose and we work on the preliminary design, which is working from the top down. We begin with what the architecture of the system is going to be and how are we going to break this up into different subsystems, and then writing specifications for those subsystems. We might also have to be investigating, do we have all the technology available to us that we need for this particular product idea? And if not, make sure we finish up the development of that basic technology before we try to turn it into a product. Or if we have alternatives of different approaches we might take, we'll spend some time to make the best choice. Which technology of all those available for our critical subsystems are we going to utilize in the final product? Then once we have an architecture and subsystem descriptions, then we can really turn the engineers loose on designing the individual components. And from that, we have to turn our subsystem specifications into individual component specifications, or we have to design things. If we're mechanical engineers, maybe we're designing some machined parts, or if we're electrical engineers, we're probably designing either a circuit board and choosing what elements are going to go on that, or maybe we're designing an integrated circuit and a whole new circuit that doesn't exist yet. Once we have all those individual pieces designed, well, then we've got to go get some examples so that we can bring them all together and make our first prototype of the complete system. So we make our first test models out of these newly designed components. Usually we don't make too many of these at once because they're rather expensive. So we have to go have somebody fabricate the components that we've designed. We have to assemble them into subsystems, test those out, and get those working together as a subsystem, and then put the subsystems all together in a full working prototype, and then do a whole lot more testing to verify that that prototype works. Once we have the basic functionality going, then we'll probably subject our prototypes to some detailed design verifications and make sure that all of the product specifications are met, and also that the product can work in whatever extremes of environment or conditions that we want it to be able to operate in. From that testing, we usually discover a few weaknesses in our designs, and so we go back and go through a design iteration, a revision in the design, maybe all the way down to the component level to make them more robust or make them easier to manufacture. And then once we have those design revisions, we'll go send those drawings out and have someone fabricate some pre-production parts, the first version that were meant to be made on a manufacturing line. Now, in conjunction with designing the individual components of the product itself, in parallel, our manufacturing and testing engineers will also be developing the tools that it takes to manufacture those devices. So in pre-production, what we try to do is not just verify that the product is good, but that the processes that we have, the tools that we have, the manufacturing facilities that we have can produce those designs, those products that we are shooting for, and can do it reliably, can do it in a cost-effective manner. So we'll actually build some first products off the pre-production tooling, the new factories, the new tools, the new test systems, run those through and see how smoothly those operate, and then take those first units that come off the line and run them through a series of verification tests, again, to make sure that the manufactured version meets all the specifications and are robust over all the ranges of temperature that we want our system to operate in. Once again, we usually learn a few things in that process, and so we'll go through another design revision, perhaps in the tooling designs, maybe even in the original product component designs, may be modified to make them better or more robust or more cost-effective. And then once we have what we consider a good production design and good tooling, then it's time to turn on the manufacturing line and start launching the product. So we get our first units off the final manufacturing line and process, start sending them out to customers, start selling things, hopefully starting to make money back. And then we're also investing in not just the manufacturing of products, but in selling them, in marketing them, in taking care of them, and taking care of our customers out in the field. After that, the product usually moves into a product maintenance phase, where we still use design and manufacturing engineers to monitor our manufacturing process, monitor the quality of the things going out the door, and as time goes on, as there's shortcomings that are discovered in the field or things that are particularly expensive we want to make more manufacturable or more cost-effective, then we'll continue to tweak the design of the product itself or the manufacturing tools to improve the reliability of the products that we produce and reduce their cost over time. Eventually, when another product comes along that's better than ours, or we've run through all the ones that we wanted to produce, we'll go through a production shutdown. So this is the end of the product development cycle. Hopefully, if you have a series of products, the team of engineers then move on to the next generation, the next version, and bring that online. But sometimes that's not always the case. So these are the steps that a product would typically go through to go from idea to a product out the door that someone could actually buy from us. Now, let's talk a little bit more about the first stages of these cycles, because that's what we're going to be taking you through as part of EE 151 and as part of your design project. Again, it starts with this idea phase, this identifying the need and opportunity. Now, typically that would be carried out by marketing folk or business folks in your company who are in touch with the customers or talking to new potential customers and gathering ideas from them of things that they might need. So they would ask questions about what do those customers want? What needs do they have? Particularly what needs do they have that are not being met by other current products or other current suppliers? Are there some problems that they have that they're plagued with that they've been unable to solve or unable to solve well that we might be able to help them with? And particularly then we think about what solutions can we provide that maybe our competitors can't or just choose not to. We're trying to find here what might be called a niche a little place in the market that we could produce a design solution that's going to be beneficial to the customer, that's a little different from what everybody else does, that gives us a little advantage in the marketplace that way, a competitive advantage. So we're trying to come up with a winning combination of what are the features of our product need to be, and also what price we can sell it at. And those two things together, the features and price, form what's called a value proposition. The value proposition is a very simple concept. Mathematically, you can almost think about it as it's the sum of all the benefits that we're providing to our customer, and from that we subtract off the price. Now, you can't really do this numerically, but this is sort of the equation that goes into through all of our minds as we make the decision about whether we're going to buy a product or not. We consider, what are the things that are important to me? What are the benefits I want out of this product? And does this product give me enough of those benefits? And from that positive place, I'll subtract off the price. If you give me all the benefits I want, but you charge me too much, I might not buy it. If you don't give me enough benefits and charge a lot of money, I'm definitely not going to buy it. If you give me most of what I want and you ask me to pay you a reasonable price, then I'll probably have a winning value proposition. Even better, you give me all the benefits I want and you do it at a low price, well, that for sure is going to sell. Now, as a producer, as a manufacturer, you're trying to find kind of the sweet spot there. You want to find those benefits that are most important to somebody, that will most motivate them to want to buy your product, your solution. And then you're trying to find the price that they're willing to pay for that. And you need that price to be as high as possible to maximize the amount of money you get back coming in to offset the investment that you've made to produce that product. Now, to illustrate this idea of value proposition, do you own an iPhone, or probably do know somebody who does? The iPhone's a good example. And if you think about why are the reasons that someone buys an iPhone instead of any of the other myriad other kinds of smartphones. Now, I know some of you non-iPhone users may say, oh, people are crazy to buy iPhones. But even that, you say that because of your own assessment of what the value proposition is. Now, why do people buy iPhones, though, when they tend to be more expensive than the other brands? Well, again, by our idea of a value proposition, they must be providing some benefits that people really want and they're really willing to pay for. They're even willing to pay a premium price for those particular benefits because they're very important to them. So what is it about an iPhone that makes them so unique, so different, which really differentiates them from others? Well, the gaps getting smaller and smaller, but particularly when they first came out, the things that really differentiated the iPhone, its key benefits, were that they were really easy to use. It had this very intuitive interface. That's actually been Apple's hallmark in all their products. Their other thing that was very attractive about them is that they had a very sleek, cool kind of design. Their industrial design, the look, the feel, looked expensive. It felt nice in your hand. What we would call the industrial design was very well executed. And it had to do everything you want, and in this case, usually more, originally more than most other smartphones could do. Now, again, the gap is closing. But these are the key features. And in fact, these three benefits are Apple's brand. Now, by brand, we mean what is the key features of all of their products that comes through all their products, comes through all their marketing, comes through everything they do. And beginning with their first computers, even the early Macintosh computers, the things that Apple did to differentiate themselves from everybody else, to encourage you to spend usually more money for their products than anybody else's, was that they provided these key benefits. It was easy to use with an intuitive interface. It was sleek, cool, something you wanted to own, and it did everything possible that you could want, and certainly more than you could do with the competition. So that's been Apple's brand. They've been very successful, and even in the recent announcement of a new iPhone, they have iPhones that coming out with prices that no one has seen before, and people will buy them because they achieve these key benefits in a way that resonates for some people. Now, everybody doesn't see this the same way. These key benefits are not universally desired. There are some people who, particularly engineers, who that ease of use, that intuitive interface is not quite so important. There might be some other features because we are technology savvy. There may be something else that we're looking for in a phone. So we might not have the same kind of value proposition as other people. But it turns out there's enough people in the world who really like Apple's value proposition that, again, these key benefits are so important to them that they're willing to spend a little more money for it. So hopefully this gives you an idea of what this idea of value proposition is, and it's something that if you work in a competitive product environment will always be kind of driving at the front end of the products that we choose to make and the ways that they're sold out in the marketplace. Now, price is the other side of the equation here. Again, iPhones are generally more expensive than other phones. And so we can ask ourselves, why is that so? Well, in order to answer that question, we have to make sure we're clear about the difference between the cost of a product and the price of a product. Those are two different things. Sometimes the terminology is used interchangeably. Generally, though, when we talk about price, we're talking about how much money is somebody willing to pay for your product? How much do consumers give you back for the fact that you produce their product? That's the price. That's if I go to a store, that's how much we have to pay to get a hold of your product. And price is actually governed, the economists would tell us, by the law of supply and demand. That there's this balance between the demand that people make, which is driven by our value proposition, and the supply that we produce. And in that, price is the one knob that we can change to change the number of units that we're going to be able to produce and sell, or at least sell. The higher the prices, the fewer the number of people who like our value proposition, and the number of buyers goes down. If we reduce the price of a product and giving them the same benefits, well, more people are going to want that. So we have this trade-off between demand and price. Now, cost, on the other hand, is the total of all the expenses that went into getting that product into the consumer's hand. And that's a different thing that may or may not be related to price. Now, to be a successful manufacturer, for sure, we need the price of our product to exceed the costs that it takes for us to get that product out there. Now, what are the different elements that make up the cost of a product? Well, a couple of things come to mind really obviously to all of us, but there's a number of ones that we don't always think about, and actually a number of places where we as an engineer will influence the cost of a product pretty significantly. Obviously, the raw materials that go into a product are part of it. Now, probably we had to hire some people to put those components together, and so there's usually some assembly labor. Now, for sure, if we're making these in any kind of volume, we're going to have to invest in some tooling to make the components, tooling to help us assemble them. Maybe there's even robots assembling them, additional tools to test them as we go along. So quite a lot of tooling that goes into the manufacturing process, and those are things we're going to have to pay back the money for. We're going to have to earn enough money to justify or to pay back the cost of those tools. There's this big additional thing, it's a term you may or may not have heard of, called SADA, S-A-D-A, Sales, Advertising, Distribution, and Administration. That's all the kind of marketing, sales, and administration pieces that get added on top of the cost of a product. If we produce something and it's the best thing in the world, if nobody's ever heard about it, if there's no marketing, if there's no advertising, doesn't matter. We're not going to sell any. If we can't get those products into the customer's hands, if we don't have a way to distribute them to them, if we don't have warehouses to store them in, if we don't have trucking to take them from where they're manufactured to where they're going to be sold, we're not going to sell anything. And all products, all companies have administrative staff. You have managers, you have secretaries, you have people who are keeping the lights on. Someone's got to pay their salaries too. All of this has to come out of the money that we make back when we sell products, so we can consider all these things that we had to pay for part of the cost of the product. The packaging of a product, that's also something we have to not only pay for, but probably design and have manufactured. Again, there's the cost of shipping things from the manufacturing site to our warehouses, from the warehouses to the stores that they're going to be sold at. Paying for that trucking, those warehouses, that's all part of the cost of a product. Every product has to be tested to make sure it's safe, to make sure it doesn't interfere with communication systems. So there's a number of safety and certification tests that all consumer products have to go through, and we have to pay for that testing and pay for those certifications. You may have heard of some organizations like UL, CSA, the FCC. There's a number of requirements that if we want to sell things, we have to prove to these agencies and organizations, some of them government organizations, that our product is worthy for sale. If you're making medical devices, well, then you've got the Food and Drug Administration that is also has to have your product certified. So a number of different agencies that we have to take care of. And again, the cost of doing that and getting those certifications, doing that testing to verify our product is okay, goes into the cost of the product. Once things get out there, well, not everyone works perfectly forever. Sometimes some get sent back to us to be replaced. So sometimes there's repair and warranty costs. And so if we're part of the design team, this is one place where the quality of our work will affect the eventual profitability of the product. So if we make design systems that are reliable, robust, easily testable, easily fixable, the more we do that, the less cost we're going to incur down the line when consumers start using our products. And so people who are going to hire us are going to care a lot about how well we are able to do our designs, how reliable we're able to make them. And are we paying attention to whether they're manufacturable or not, or easily supported in the field? So as engineers, we have to think about all these things. Now, product ideas sometimes flow out of new technologies that weren't available before. And so someone's got to pay for that research and development that went into creating that new way of doing things, that new technology. And again, ultimately, that has to be paid back by the sale of product. And so we consider those research expenditures, the engineers and scientists that go into developing those and all the tools and that went into that as part of the cost of our product. And of course, if you're working as a design engineer or a development engineer on a new product, your salary is part of the cost of a product. Your company's been paying you to design components, maybe to help architect things. You've been involved in this whole process. And so your daily salary is part of the cost of a product, has to be made back through the sale of those products. Not just that, but you're probably using computers and maybe some fairly expensive CAD tools and to help you do those designs. And you're probably sitting in an office where someone's got some lights on, paying for heat and air conditioning and setting up networks and giving you secretarial support and managers over you. All that has to be paid back by the money we make by selling product. And so all that goes into the cost of a product. Now, the basic equation in all this is that there has to be a difference between the price of a product and the cost of a product. And we need the price of the product to be higher than the cost of a product in order for us to make money. And that difference is what we call profit. Now, profit is sometimes seen as a bad thing. In the commercial world, though, you need to have some profit in order just to keep the business going, because if you never recoup the money that you put into a product by selling enough product at the right price, then you have a problem. To be successful and to keep being an ongoing business, you always have to make back more money than you invested. Now, we're going to look at this picture a little bit more. The steps that we just talked about, the beginning of identifying a product need, the customer requirements, and turning that into a conceptual design, a product specification, that's the stages we're going to get you started on this week. So what we want you to do is a description of a design challenge, a product that we need you to design, and a set of customer requirements, a document that could have been produced by going out and talking to some potential customers and saying, what do you really need to solve a problem that you have? And these will be written in terms of words, describing some things we want it to do and some features we want it to have. We'd like you to take that marketing description, that customer kind of description, and turn it into an engineering product specification. Now, what goes into such a specification? Well, first we start with a product name, which we'll make up. Then we want to understand who is going to use our product, who's the intended user, the customer, what context is going to be used in. So we want to have in our specification a clear description of the customer. who might use it once it's finished, what are their unique needs or circumstances or environment that relate to the requirements that are going to be imposed on this project, so we know why is it being required this way? Why does it have to have this feature? If this project is part of a bigger system solution that the customer needs, well, then we need to understand where does it fit in that total picture and what's its interface to those other components. Speaking of which, then the first way that we conceptualize a product is through something we call a black box diagram. This is literally a diagram, which is a black box that describes the product that we're going to make. It's a black box, an empty black box, because at this point we have no idea how we're going to produce that product. Well, we may have some ideas, but we don't have a design in our hands. We're assuming we're going to be able to fill in that box with some designs that are going to meet the needs of the specification. However, what the diagram allows us to do is identify our boundaries, identify the interfaces between our system that we're designing, our product we're designing, and the outside world. And particularly what's coming into our system, into our solution, what is it producing out? And again, if it's one element in a larger system, again, what are its inputs and outputs, but what is it talking to? What are the other components that we're interfacing with? So we have an idea of where our boundaries are and what we have to work with and what we have to produce. As an example, if we were going to make a black box diagram of a coffee maker, well, we first ask ourselves, what are the inputs to a coffee maker? If you're going to make a cup of coffee, what kind of information or materials are coming into the process of making a cup of coffee with an automatic coffee maker? Well, certainly we have to put some ground coffee in. We're probably going to put a filter in. We're probably going to add water into it. Somewhere there might be a timer to say when it should start brewing. We have to put some power into it. Usually we plug it into the wall, so we have 120 volts AC coming in. And what's it producing? Well, hopefully a delicious cup of hot brewed coffee, but also there's some refuse to deal with. We have these used coffee grounds coming out, and we have a used filter that's got to come out. And maybe there's an indicator light or a beep to tell us that the coffee's ready. So as you see, we define the inputs, the outputs, and even though we might be designing the coffee maker, again, we make no assumptions about what that design is going to look like. We just make it a black box. Also in a product specification, we're going to include a set of the design requirements. We want to capture what are going to be the functional requirements, that is, what does our project have to do? And this will use a brief listing and maybe some short descriptions of the major functions that the project is supposed to provide or accomplish, and any special features that are supposed to be included that maybe aren't necessarily a functionality, but a way that it goes about producing that function. So to differentiate these, a feature is what something has, a function is what something does. Or using the old definition from Wood, functions are the product's answer to the set of the user's tasks, whereas features are the tools inherent in the product used to perform those functions. So for example, if you're placing a telephone call, making that call is the function. Having a dial tone or a touch tone keypad, those are features that are used to accomplish the function. In addition to the list of the features and functions, what we want to do is also capture what are the quantifiable performance specifications or performance metrics that our product must achieve. These are usually numeric, quantified specifications for at least the minimum level of performance that has to be achieved, or maybe a required range of performance that the product has to achieve. Now, amongst these features and functions and performance specifications, some of these will be constraints, some of them will be product criteria. Now, these are two words again that sound similar, but let's see if we can differentiate them. Constraints are something that the product absolutely must do, whereas criteria are things that affect how good the product will be perceived by the customer depending on what level we choose. So for example, constraints might be considered the minimum level of performance that's required, or the maximum level of undesirable attributes like cost that are allowed. So these are constraints. These are limits that we really can't bend. These are product features that must be included, or the customer is just not going to want the product at all. So again, this is kind of minimum or maximum level of things. Criteria you might think of as levels of goodness. These are metrics or benefits that the customer is going to use in their equation of choosing whether they want your product or an alternative. Again, these are maybe additional features that we're adding in that bring some key benefits they like, but maybe these aren't really super compelling benefits that they absolutely must have. They could be levels of performance that are a little better than somebody else's, so more is better, or it could be a lower cost. Sometimes less is better. So these are more squishy things that we get to kind of choose what level we're going to come in at. But there's usually a direction, more or less is better. And these become part of the kind of relative weighting that the customer uses to, again, choose whether they're going to buy our product or somebody else's. So again, constraints are things that we absolutely have to deliver on in our design. Criteria are things that, well, we might have some room for negotiation there. We might have some trade-offs here to make between, well, we can give you a little more of this and if you get a little less than that. And so this is a place where we get to be a little bit more open-ended in our design. Now there are two constraints that are always present in every product. That's the cost and the time. Cost being the budget and time being the schedule. Now, costs would have two elements. Both we'd be talking about the product cost, the eventual cost that it makes to produce one unit. That's those raw materials, that's the assembly labor, that's the tools and factories, those things that we're amortizing over the production to make back our production costs. But also we have this development cost, the upfront money that we're putting into the product through research, development, design, building prototypes, building up pre-production tools, pre-production units, testing them, certifying them, all this money that creates things that isn't product we're going to sell directly, but that went into enabling us to make those. That's again a cost that is constrained. So if you're working on a new product design, you'll have a target budget for what the product cost is going to be, what its material costs are going to be, its manufacturing labor costs. You'll also be tracking the budget of how much the design team is spending in salaries, in tools, in prototypes, in materials to produce those first prototypes and to get those first units out the door. And there'll be constraints on how much money your company can afford to use in that development. There will also be costs and budgets around, again, marketing, sales, advertising, customer service, customer support, all those things we talked about before. Now, what's this constraint with time? Well, it comes in a number of ways. You've probably heard the term time to market. Time to market is a term that means from when I start with an idea and decide I want to go make this product to when I actually get something out the door into a consumer's hands, we need that to be as short as possible for a number of reasons. The sooner we get out, we have this adage that time actually is money in the world of manufacturing products. Besides us working on our ideas, our competitors are out there also, and they may have new products coming out. And we have to worry about, are they going to bring out something sooner than we are that has features similar to what we're going to produce? If you're the first one to market with a new product or a new key benefit or a new key feature, for some period of time you have a monopoly and people are willing to spend more money for your product. As soon as somebody else comes out with something like very similar, well, if you're the second guy out there, you've got to do something better or make it cheaper or both. You've got to have a way of tweaking that value proposition to attract people to buy your product instead of somebody else's. So if you want to have a profitable product, being the first one out is really the way that you need to go. Sometimes we're working on products that are a whole new way of doing things is down the line. And so, again, the sooner we bring out our last generation of something, the more money we'll be able to make back by selling more product before a new alternative solution comes along. Now, here's an interesting chart that kind of tries to show this graphically. The independent axis, the horizontal axis there, is time. And all the way to the left is when we kind of start a whole new product development. We've chosen we want to make a new product and we want to start launching off and making it a reality. As we move to the right in time, time is going by, we're moving through the phases of the product development cycle. Now the vertical axis is the cumulative cash flow. That's a fancy economic term to say what's happening to money at this point. Is it positive or negative? And as we start spending money, we start accumulating how much money we've spent over time, and then we go negative. And as we start selling product, well, then we start getting some money back, but that doesn't make us positive immediately. We've got to make back whatever hole we've dug. And so with this kind of indicator of cumulative cash flow, we look at the start of a cycle. Well, we get an idea, we start employing people to develop that idea, to come up with a conceptual design. Doesn't take a lot of people to do that, and we don't start spending a whole lot of money yet, but we're definitely going negative. Once we have a product concept, we start employing design engineers and manufacturing engineers and testing engineers and start paying their salaries. They start buying parts and prototypes and things like that. And then we start accelerating the rate that we're spending money. And we start going more and more negative more and more quickly until we get to the place where we're ready to start getting a manufacturing line going. So once we have our initial prototypes working, then we're going to start investing in the manufacturing facilities, buying factories, buying or building production tools, and that's where a significant hole starts getting dug, because those tools, those facilities, all that manufacturing capability requires a lot of upfront money to buy the things that you need. And so before we've even had one product go out the door, we've dug a pretty deep hole before we get to the product launch. Now what happens at this point? Well, at this point we start sending some product out the door. Hopefully people start buying them. And now we might start turning the curve around. It may not turn around right away if there's a difference between how much the price we're getting back for our product is from the costs. But let's assume they are. Then we start climbing our way back out. Now products can go any of a number of different ways. If it's like this topmost curve, this is a very successful product that came back positive, earned back all the money that it had spent up front at some point in time, about halfway through its life cycle, and then remained profitable for quite a while until we announced, well, this product's time has ended, we're going to phase these out, and then we kind of shut off the production line, sell off the old inventory, and start having some shutdown costs, which take away a little bit of our profitability. But we end up with the product having accumulated a positive cash flow and generated some profit for our company. That would be considered a successful product. If we follow the red line there, well, that's a product that never quite recovered back the money that was put into it to produce. So we never quite crossed into that positive cash flow area, but remained negative through the whole life cycle of the product. That kind of product is one that if you're a large company like Sony or maybe even Apple, you can afford to do a couple of those kind of products and still survive. If you're a startup company though, and you never make money back, never become profitable, well, you've never earned any money to fund your next product, and so it's time to close the doors. Your investors won't necessarily give you more upfront money to work with. You've spent all that. You never made it back. You never made them a profit. And so you're probably done. And so these curves really dictate whether or not your company is going to be an ongoing corporation or not. So us as engineers, where do we affect these curves? Well, how well we do our jobs affects how well customers like our products. And so that can affect the price they're willing to pay, the number of units they're willing to buy, the amount of time that it takes us to design products and to do it well. Well, that's going to dictate a lot about how deep that hole is at the beginning. If we're going through a lot of design iterations, a lot of rework, or if something that we design isn't robust and we have to continually make design changes and slow down the readiness of the manufacturing facility, well, we just start digging some really deep holes that we are never able to recover from. So as engineers, the things that our companies that employ us are going to worry about is how well can you do your job, how good are you at your job, and how quickly can you do things. Do you know how to do your job so well that you can be very efficient as well as effective? Those are two attributes that people will be looking for in your career as future engineers. Why? Because it's necessary in order for your company to be profitable, in order for them to continue to pay your salary, because we need to make good products that people want to buy and are willing to pay more for than it costs you to produce. So while we don't spend a lot of time learning about marketing and economics, they really have a big influence on what our career paths are going to be like as engineers and our successes. So cost and time are usually, again, both constraints and criteria sometimes. I mean, they are constraints in that customers will not buy our certain products if the price exceeds a certain level. And it's also a criteria. They probably like our product better if the price is lower than the competitors. And how much they like it is directly dependent on what price we charge for it. And so this is a case where cost is both a constraint and a criteria. Now, getting back to the product specifications we're going to produce, there's a number of other elements that are usually part of that. Again, to bracket the time aspect, all product specifications will tend to have a timeline, which identifies the major tasks in the rest of the development cycle, what milestones are going to be hit along the way. And this would be the proposed schedule for the product. This becomes the basis for the business case that people put together when they try to predict how much money is going to be spent before we start producing product. And so it's an important part of the specification. And of course, the budget. How much money is going to be set aside for paying for engineers, for buying and building prototypes, and having new kinds of components manufactured, of buying any special tools that are required, of running the tests that are needed. This will all be budgeted up front and will be given as some constraints to the design team. So your assignment for this week is going to be to turn that list of customer needs and requirements into a good product specification document. And by that we mean we want you to find those functions that the product is supposed to perform, find the features that need to be included, pick out any of the performance metrics that are required, and then look at each of these and determine, is this a criteria or is this a constraint? We really want to know which ones are the hard things that we just can't change and which are the ones that we might be able to play around with a little bit. Either way, the guidelines for the assignment are posted on Polylearn, and they'll guide you through the rest of the exercise. So with this, I hope you enjoy the project that's coming up. Hope you feel like you got something out of this little preparation video. Teach you a little bit about products and what every product goes through out in the real world. And looking forward to seeing what your solution is going to be to the design challenge we present you this week. See you soon.